Again, tonight we kick off our special guest with Jeff Inanucci.
Iannucci.
Iannucci, that's close. And we'll give you his personal experience and knowledge of his topic called Breaking Bad Habits, Solutions for Common Query Anti-Patterns. And we hope that you will learn something new and apply this to your passion or your career. So we hope, again, that you enjoy this presentation. Jeff, just out of curiosity, how would you like our guests to respond to your questions? Would you rather them individually? Should we hold off?
If you have, I've got like several sections throughout this session. I think there's about 7 or 8 sections. So at the end of each, if I'll just ask if there's any questions regarding that.
Perfect.
People can just unmute themselves if there's anything in the chat. Since I'll be sharing the screen, I may not be seeing that. So if someone can just pipe in and let me know.
Perfect. We appreciate that. Thank you. And again, Jeff, the floor is all yours. Thank you once again.
All right. Let me share my screen here. Make sure that you can see. How's that look?
Perfect.
Okay. All right, everyone. Welcome. First of all, thank you to the San Diego SQL Server Users Group for inviting me to give this presentation. This is a presentation that is very dear to my heart because I get to share some of the things that I see over and over again, especially since I've been working with Straight Path as a consultant. See people do, not realizing that they are actually writing SQL that is causing their computers, their servers to do much more work than necessary. So if you're an intermediate level, I'll say, or even beginner level developer, or even a database administrator that's writing T-SQL, hopefully this session can help you improve your T-SQL skills. Now, in case you're wondering who I am, my name is Jeff Iannucci. And I, as I noted, live here in Arizona, but I work for Straight Path Solutions, where I've been a consultant for a little bit over a year now. I'm also a content author at Pluralsight, and I'm the author of the upcoming book, Learn SQL in a Month of Lunches, which has an advanced publication that's available if you want to learn more about the SQL language, not just T-SQL for SQL Server. So this session, we've got 3 goals. 3 is a magic number, right? First, I'm going to show you what are some of the T-SQL anti-patterns. We're just going to address specifically T-SQL in this session. What are some of the T-SQL anti-patterns that I've seen and even honestly done throughout the years? I'm going to explain to you why they're anti-patterns, and then we're going to talk about how we can correct them. Now, that's the most boring slide, I think, so far in this deck. I don't have any demos, but I do have a lot of screenshots and code in these slides, so there'll be plenty to learn here. But I do want to warn you ahead of time. We are going to be talking a little bit about indexes, so a basic knowledge of clustered indexes, non-clustered indexes, seeks and scans would be helpful here. We're going to look at execution plans, which are critical to understanding what our queries are doing. If you've never looked at execution plans before, great. Today's a great day to start, right? And I hope you like dogs because there's a lot more dog pictures. We'll get to that later. Now, the term anti-pattern is kind of it's a snazzy term, right? It's probably a very eye-catching term, but what exactly does it mean, and where did it come from? Well, best I can tell, at least within the line of the world of SQL, it started. This gentleman, Bill Carwin, wrote a book over a decade ago called SQL Anti-Patterns, in which he described an anti-pattern as a technique that's intended to solve a problem, but it often leads to other problems. And throughout his book, Mr. Carwin has different chapters outlining different anti-patterns, none of which we're going to talk about here today because most of the anti-patterns in that book are design anti-patterns. That being said, it's a great book. It's a fantastic book if you want to learn more about the intermediate to advanced usage of the SQL language. But throughout his book, he presents each chapter, each anti-pattern in a particular method. First, he gives you a scenario where they're used, and then he provides an example of the anti-pattern. He gives the anti-pattern a name, and he explains the reasons why it's an anti-pattern. And finally, he gives you a solution to the anti-pattern. So throughout this session, I've adopted the exact same thing. So I guess you could say I'm ripping him off a little bit, but I think it's very easier. It's much easier to understand each of these anti-patterns as we go through them if we address each of these 5 points. Now, again, the anti-patterns that we're going to discuss all have some common features. First, they're all common T-SQL solutions. They're going to be things. I'm going to show you anti-patterns that I guarantee you've written or you've at least seen in the code that you are supporting. They're all going to return a correct result. So these anti-patterns don't give us the wrong result. They're just the wrong way of going about things because they perform unnecessary work. They're going to make our SQL Server do more than it needs to. They're going to make our queries perform worse than they need to. So I guess if you want to look at it, this is a query tuning session of sorts. But you know, again, we're trying to address things that are very, very common, as you'll see. Now, if you read the abstract, you saw that this is presenting a narrative because they say, hey, if you want to make a good session, make sure there's a narrative around it, right? So the narrative of this session is we're going to look at who is using these anti-patterns, right? And every single example, we're going to have Junior, who's a junior developer, is going to become a more skilled developer throughout the session, looking at designing code to respond to a request from their boss. And in case you're wondering, this is who works at Adventure Work Cycles. Clearly, they have a very open work from home policy and a very diverse hiring policy as well. Moving on, let's talk about the first type of anti-patterns I want to talk about are selection anti-patterns in our select statement. So the first request from the boss, and this is a much more fun session when it's in person because I can ask someone to read these out loud, but I'll spare you that since you're a virtual audience here. We'll just say that the boss requests, hey, let's find anyone named Barker because maybe we are related. So Junior's going to write a query to go find anyone named Barker from the person table. And even, I guess, fairly savvy T-SQL users may note that the first anti-pattern we have here is the select star, right? Now, a lot of times select star we have to use just to try to survey a table, but to put it in reusable code, maybe not such a good idea. Why? Well, what is select star doing, right? It's reading more data, it's using more memory, it's taking more CPU time, right? Because it's got to read more data. So again, we're starting with a really basic example. We'll work to more advanced examples throughout the session here. And in this basic example, let's look at the execution plan. Again, you may not have seen execution plans before, but let's take a quick peek here at what the execution plan would look like for this query. We'll come back to this in a second. As you can see, there's some operators. That's those little icons that you see. There's some, this isn't an actual execution plan. When you see the 0.00 seconds, that shows us the actual time used. And then below that, the number of rows of the number of estimated rows. And then, of course, there's cost estimates as well. Now, what determines your execution plan? Well, that's a whole bunch of stuff, right? You know, the query you wrote is part of it, but there's also what indexes are there to support your query? What statistics are there? And are they recent and accurate in representing the data distribution of whatever tables you're querying? You know, there are certain rules in the optimizer that based on your query and those statistics that it's going to pick certain operations, you know, a nested loop versus a merge join, things like that. And of course, your server and database settings will affect these things as well, things like parallelism. If you want to see an execution plan, if you've never looked at execution plans before, you really should start looking at them for your queries because they will just open up a whole new world and tell you what's going on in them. The easiest thing to do in Management Studio, you can click on this little button which says Display Estimated Execution Plan. You can actually click that before a query is executed and see an estimated execution plan. Now there's one that says include actual execution plans, which more often than not is going to be the exact same as the estimated plan, just with additional information from the actual execution. That's going to happen after you execute your query. And for SQL Server 2017 and more recent, we now have live query statistics, which is a really neat feature that will show you the execution plan and count the rows and the time as it proceeds through the query. There are some hotkeys for 2 of the 3. There isn't a hotkey for include, shortcut for include live query statistics, so maybe someday, right? If you want to go hardcore old school, you can just put set show plan text on in your T-SQL statement, and it'll give you a different sort of execution plan. I don't advise that, but I just mentioned that there in case anyone's really been doing this for a long time and you are using this. I admire you tremendously. Let's get back to our select query. We're going to give it the name, like we said. I'm going to call this unnatural selection because with our select star, what we're doing is we have a supporting index for our predicate, right? For the filtering part where it said where last name equals Barker. But because we have select star, we got to go grab all those other extra columns, and that's where we do this key lookup. But you can see the estimated cost of this key lookup is 51%. That's just an estimate. When you see key lookups out in the wild caused by this, they're frequently more than 51%. They could be 60, 70, 80% of the cost of a query like this. So a better way, of course, only select the columns you need. Keep that T-SQL nice and tight. And then you won't have that key lookup, right? You can just use the supporting index as needed. Now, again, this is a really basic example so that we can set up the rest of these and how we're going to measure them. And one way we can measure them is by setting statistics IO on. Now, this has nothing to do with your table statistics. If you haven't set this command before, what this is going to do is it's going to provide a message output at the end of your query, and it's going to show, among other things, the number of reads, page reads, that your query is doing. You'll get something, it'll say an output like this and say, okay, for this table, I did this number of scans, this many reads. Logical reads is the best one to focus on because physical reads can vary, right? If the memories, or if the data pages are already in memory, you don't need a physical read. If it's not in memory yet, well, maybe it does need. Logical reads is definitely one of the ones that you should focus on if you're just now starting using this, because that, if you can reduce the number of logical page reads, hey, you're reducing the amount of work that SQL Server is doing, and that's exactly what we're going to do throughout this session. We can compare the logical page reads of select star versus select only the columns that are in that supporting index, which in this case is a very, very small amount. But as you can imagine, if you have built select star into reusable code and it's selecting star, selecting all the columns from some really large table into a temp table or into a CTE, whatever, you're forcing SQL Server to read more than it needs to. Okay. With that all set, let's move on to the next query where the boss is going to make a little more complicated request. Hey, I just had a killer workout chasing a yellow car. It looked magnificent, and I want a list of orders with any yellow products ASAP, right? Because if your boss asks you anything, it's always ASAP. So Junior's going to write a query now. And Junior realized that there was some extra records in there. So Junior said, all right, select distinct sales order ID from these things where the color is yellow. And as you can probably imagine, the anti-pattern here is select distinct. And I say that because select distinct gets used a lot of times to cover up for mistakes of extra records, right? Extra rows that show up in your results set. I'm going to call this anti-pattern distinct disadvantage because if we look at the execution plan for this, you see right here, this is where a big chunk of the work is done. We have a join and then a hash match aggregate. Now, if you're familiar with an aggregate is, right, an aggregation, typically, if I say to you, write a query that does an aggregation, right? It would be something like, give me a sum or give me an average, give me a minimum, a maximum, right? You're going to be writing a group by, right? Here's the thing, a lot of developers don't realize when you use distinct, you're basically using group by as well. And so if you look at the execution plans of these two queries, let's just say select a distinct sales order versus select the sales order group by, you get the exact same execution plan right there. And right in the middle of it is your stream aggregate. In this case, it's a different aggregation operation, but it's an aggregate. I've got to take all the results and then I've got to group them all together. A better way to do this, of course, would be to better understand your data. Maybe your joins aren't correct. Maybe you need to join on one or more additional columns to filter those extra rows, those duplicate rows out. Or maybe you even have to do something like this where you do a where in, so that you're only matching these order IDs that may be duplicate in one set of results in your subquery versus, not duplicate in the other. Doing this alone will get rid of that aggregation. And we go from having this hash match aggregate that we had in our previous query to now something called a right semi-join. Semi-joins are an operation that happens whenever you have an in statement. And it doesn't have that aggregation anymore. We're going to do a lot less work. How do we know? Well, let's look at the logical reads of the two queries. You can, again, run these in AdventureWorks 2019 yourself and see. On this one, this query, you're going to get 214 logical reads. And on the next query, you get 128. Now, I ran through the first one really quickly, but I just wanted to stop and see. Does anyone have any questions at this point?
The floor is open. Welcome to turn off your mics. No questions?
All right, moving on.
Going once, going twice.
Okay. It's a bidding war here. Awesome. Next request from the boss, right? Hey, can I get a report of how much we've sold for each product? And later today, I might ask for a report for one product, or maybe I won't. So Junior's going to have to write a query here that has to account for, or has to write an object that's going to account for some sort of possible variable, right? The product ID variable. Junior decides to write a function for getting sales, go get the sales for this report based on a product ID, which seems like a really decent idea, right? Junior's advancing out in their skills. But I want to talk to you a bit about these functions. These functions sometimes don't operate in the most efficient way. In fact, barely operate in the most efficient way. I'm going to call this anti-pattern scalar dysfunctions, because these user-defined functions, these scalar functions, in the execution plan here, this gets a little bit dicey. This is if we run that query there at the bottom that Junior had, this is what the execution plan looks like. Now, it may look like, hey, compute scalar, that's our function part thing. Estimated cost 1%. This isn't going to do much at all, right? But this is the actual query plan, right? So this means it has the actual statistics in it for what was happening. And you will see that that very first index scan, which is estimated to be 99% of the query, completed in less than 1/1000th of a second. But the compute scalar, the actual function part, even though it's estimated at 1%, is close to 1/3 of a second to evaluate 504 rows of yellow products. So that's not very helpful, right? A better way would be, how do I put this? Try to avoid using these user-defined functions if at all possible. They're very convenient from a standpoint of execution, right? I can just plug something in and then I get it. But in terms of actual work underneath the covers, they are very inefficient. They're totally an anti-pattern. And so if we write this out, the SQL that we just needed to write, and maybe we could create this with a variable instead of making it as a function, we get a whole lot more happening. But our actual time goes from what, 0.300 milliseconds to 26 milliseconds. It's 1/10 of the time. Now, why is there such a drastic difference? Again, we want to look at the properties here. If we look at that, if you hover over in that execution plan, I'm sorry, we want to look at the execution plan. If we hover over the select in that execution plan, you'll see the option to select properties. And from the properties, we can select something called query time stats. And if we look at the query time stats, it's going to show us the CPU time that's used by each of these. Again, this is just going to appear in the properties window to the right, usually to the right, unless you have it set up somewhere else. And you'll see the query time stats of CPU time of 325 milliseconds versus 27 milliseconds for the query on the right. So using that function adds a whole lot of extra overhead, and that's why it's an anti-pattern. Okay. Oh, one last thing. You also see an additional time here, right? A UDF CPU time. So you can see whenever you have a user-defined function like this, how much actual time that user-defined function is executing. Now, I know there have been some advances, enhancements made in more recent versions of SQL Server in 2019 and 2020 to help these user-defined functions perform better so that they're not like 10 times as much processing or whatever the case may be. Unfortunately, though, there are a lot of exceptions to those. I'm not even going to begin to get into this. This is just part of the page. You can go to these pages yourself and see the user-defined functions, no matter what they're trying to do under the, it's just, oftentimes it's not going to be as efficient as you want. Make sure if you are using user-defined functions that you're not applying them to more data than necessary, that you're not applying, downstream against a column on a table that has like millions or even billions of rows. If you do, I'm sure you're already suffering now with that. Any questions about user-defined functions?
Floor is open once again.
No, yeah. Isn't functions act that like a cursor? They go one at a time.
Yeah, kind of like a cursor, I guess is a good way to put it. Yes. It's, also here the row by agonizing row. Yes, they have to evaluate each value individually. So that adds to the overhead as well, for sure.
Yeah, just thinking out loud.
Yeah, for sure. But you could even test some of these things that I have here. Oh, and I should probably mention, I'll mention this at the end. All the slides here are already available on my GitHub repository. I'll have something at the very end. If you can't wait until then, or if you have to leave, you can go to github.com/desertdba, 1S, not 2, it's not desert DBA, desert DBA, and look at my GitHub repository in the presentations folder. You'll see the slides for this session. And you can try these queries yourself.
Great. Good advice. Any other questions out there? Tammy, Abdul, Andre? Going once, going twice. On.
All right. We'll move on to the next section, the joining antipatterns, the antipatterns in our joins statements, in our from statements. So here's the next request. Hey, let's find any US state with persons named Junior who ordered anything black because your name and my color are awesome. So Junior's going to write a query then. If you've ever looked at the a little in depth at the AdventureWorks, the database, you can see that there's no easy way to determine all these things. So Junior has to end up joining 8 or 9 tables here together with the predicate of with the suffix of Junior and the color of black. So what's the anti-pattern here? It's the whole thing, right? I'm going to call this anti-pattern Joinzilla, because what happens is a lot of times when you write these queries that join 5, 6, 7, 8, 9, whatever tables together, SQL Server has to try to figure out different ways. What's going to be the most efficient way to process this query? Like, which table do I start at, and how do I join them from there? And you can get an execution plan, and this actually isn't too bad. But if you see these queries that have an execution plan joining 20 tables together or something like that, it's even bigger. And as you can see, the font gets smaller. You can't see the whole thing. Try to fit it on the whole screen here. It's almost unreadable. Now, this begs the question, well, how many tables is too many tables? And I'm going to give you the answer. It's not a number, but you can tell if your query has too many tables joined together, again, by hovering over that select operator, right-clicking on it, picking properties again. We're going to look at a different property this time. We're going to look at one called query time stats, and it's going to have a value called reason for early termination of statement optimization. That's a whole lot of words, but remember that, because when you look at that and you see timeout, what that means is that SQL Server's Query Optimizer was trying to determine what's going to be the best execution plan, but it gives itself a limited time. I don't know what that time is. It's based on their proprietary algorithm, but it looked at the query and said, I'm going to give myself X number of milliseconds to figure out the best query plan I can. And it's trying options. And when it reaches that threshold, it says, well, I didn't get to try all the options, so I ran out of time. I'll just have to go with whatever I had that's the best as of that time. So it's very possible that the best and most efficient execution plan for processing that big join Zilla query was never arrived at. And you could have a substandard performing execution plan. And so what do? How do you avoid this? Well, one way is using temp tables. You can break your query up into smaller queries, smaller chunks, smaller data sets, and then join those at the end using those temp tables. If you do that with those smaller queries, then when you look at the properties for each of those select statements, you'll see their reason for early termination of statement optimization. Again, that's a mouthful, and I really hope I don't have to say that the rest of this session. The reason won't be timeout, it will instead be good enough plan found. That when you see good enough plan found, that means, okay, the optimizer did its thing and felt comfortable. It went through all the possibilities. Now, in this example, I'm using temporary tables because they're convenient. We can select into, and we can do all kinds of things. They're actual tables. They're materializing the data, right? So we can get good estimates. But I know I always get asked this question at these sessions, what about table variables, right? Well, okay, good, fair enough question. Let's look at the differences. The first thing now, they have different characteristics, different perceptions, different advantages, disadvantages. So let's go through them. Temp tables can be altered, right? If you have a temp table, and let's say throughout your processing, you need to do something like add a column or whatever, you can do that. Table variable, you cannot. Can they be truncated? You can truncate a temp table. So if you have to put data in, truncate it quickly to remove it, you can do that. Table variable does not allow for truncation. You can only delete. You can use select into, which if you're familiar with minimally logged transactions, is a very fast and efficient way to pull data into a temp table. You cannot do select into a table variable. Temp tables have statistics on them as you put the data in there. There's statistics on the data distribution, which helps make the estimates used in our execution plans, used to create our execution plans more effective. Table variables don't until recently. Until the last couple versions of SQL Server, the estimates were just one. It's just you're a variable. You got one row in there. So there have been some changes made, but they don't necessarily really improve the performance all that much. But they do wait until after you put the data in, and they try to recompile to get a better idea of what kind of data you're putting in those table variables. But it's still nowhere near as full as you'll get with a temp table. A temp table can participate in a transaction, which means if you have to begin something and you try catch an error and have to roll it back, you can do that with a temp table. You cannot do that with a table variable, although there are some situations, some scenarios where that could be a benefit. If you want to capture an error and you have to roll something back, but you wanted to remember what it was that you were doing, you could put that into a table variable, and after you roll back, the value is still in the table variable. Nothing rolls back from it because it's a variable, right? It doesn't roll back. Temp tables do not write only to memory. Neither do table variables. If anyone told you that, they're not being honest. Table variables still have to write some metadata for their structure into the tempdb database. Temp tables still write to the log. So do table variables. They have to, if you do something with a table variable, it's still going to involve a transaction that has to be logged. Everything is logged in your SQL Server database for data integrity, right? In case you need to roll forward, roll back, whatever the case. Temp tables avoid a recompile in a procedure. If you're using temp tables over and over again in a stored procedure, you may have some recompiles more frequently than with table variables. That is a definite advantage of a table variable. And of course, if you need to pass a set of data to a function, you can't do that with a temp table. You can do that with a table variable. This is, as you can imagine, one of the more popular slides. Anytime I give this in person, I don't know if anyone hears anything I say because I always just see phones out taking pictures of this slide, but whatever the case. I also get people asking me about common table expressions. Well, can't we use those instead of temp tables or table variables? Well, that's not really a fair comparison because a common table expression is something totally different. It's not materialized. It's basically a subquery that you're going to reuse, right? It doesn't actually write any data anywhere. And because it doesn't do that, it can have really poor estimates, especially if you're putting a lot of tables together and joining them, because SQL Server doesn't know what that's going to be when it goes to first process the query. And poor estimates can lead to poor execution plans. This is a really simple example, but you could have an estimated number of rows that's 65 times the actual number of rows that could be processed, or worse, with a common table expression. The common table expressions can help, but you need to know ahead of time that this is actually what SQL Server should process first, and that we'll use that as a common table expression. You calculate this part out for SQL Server first, and I'll tell you what to do, and then you can go and join that common table expression or do whatever you want to do in your join. So if you do use CTEs, I got two things to remember. First, use minimal joins. Keep them as small as possible so SQL Server can have the best estimate possible for your CTE. And, talking back with select star, same sort of thing. Minimal columns. Keep it only to the data that you need. Doing this will keep your estimates closer, but I still can't guarantee any consistency in performance, because each time SQL Server runs, it's going to be like, okay, I'll guess here because CTEs aren't materialized. Any questions about any of that?
Floor is open. John, do you have any questions?
Well, yeah. What if you have a slow drive for your TempDB? Then what are you gonna do?
If you have a slow drive for TempDB, well, you could always just select into actual tables instead of temp tables. If you need to, you could create, temporary tables inside your user database if the performance in TempDB is actually that much of a problem. I mean, that sounds like an issue to take up maybe with your systems administrator, but I understand. I work with clients who have that same sort of issue where somebody said, I'm going to buy these cards that'll be really super fast, and we're going to put TempDB on it, and then it's not. So in that case, maybe if you have better drives for your data, maybe move TempDB to those drives instead, if possible. You can always, move TempDB on restart. So that's an option. Great question.
Just asking yeah, politics at work. Those, company politics,
Yeah.
with infrastructure guys, they don't want to give up the right storage for the right job. So that's what I'm asking.
Yeah, unfortunately, you have to get creative and do kind of strange things then, but I'm sorry about that.
And as a DBA developer, that's what I'm asking. I'm just asking from a DBA perspective. So
do you help the optimizer if you use views?
If you use views?
Yeah.
So views are going to be fairly similar to CTE, because it's non-materialized unless you put an index on it that's actually, with schema binding, and you have like a physical representation of your data in there. The tricky thing about views, and that's not really, that actually could be another anti-pattern that I've seen, is when you nest views, that estimate gets more and more obfuscated, and as you nest like 2 or 3 views deep, SQL Server just kind of throws up its hands and goes, I guess this will give me 1 row. I don't know. I have no idea how many rows this is going to be, because it can look at a table, and you create statistics on the table, and it'll say like, all right, I got this many values, for Barker, this many values for Wolf, or this many values for whatever it is, for 1s or 2s or 3s, and it can, so that when it comes to the execution plan, it says, I think I'm going to have 1 million rows, or I think I'm going to have 5 rows. But as you layer that underneath views, SQL Server's like, I had no idea what that's going to be. So that's just kind of a dangerous thing about views, but otherwise at a single level, the performance would be very similar to what you would see for CTEs.
Tammy, Andre, Abdul, John, any more questions? No?
Great questions. Thank you for the questions. It means you're listening, I guess. And hopefully this is being helpful. So we're about halfway through now. Let's move along here through the requests. Request number 5. Hey, I just went for another run. Actually, I fetched the mail, and now I'm exhausted. And I was wondering, are any of our customers missing a mail address? This may be the most controversial of the anti-patterns that I'll show you, because this is one of those that I think a lot of people do. So what we have is a situation where we have a table with values that would join to another table, and we're looking for an absence of data in that other table. In this case, we have person represented. We have records rows in the person table, but we want to make sure that they're not in this business entity address table because that's where we store the email address. And so we do this left outer join is null. I do this all the time, right? I got to find something that's here but not there, and I have a value to join on. Well, that's actually an anti-pattern, and I'll tell you why. So I'm calling this avoiding the semi because what you're doing is you're avoiding a semi join, as you'll see later. When we do this left join, excuse me, SQL Server will rearrange our query. In this case, it turned it into a right outer join because it said, I'm going to change the way you're doing this and I'm going to turn this into a right outer join. Okay, cool, whatever. But this right outer join, if you look at it, we've got 19,000 and some rows in each of these tables. And when we do that left outer join, we're going to have to, because it's a join, we're going to have to evaluate all of those rows. So SQL Server ends, the query optimizer ends up saying, all right, do you have this, or do you have a value or not? Do you have a value or not? And really what we're looking for is like, we just want to know the ones that don't have it. I don't want you to have to tell me about every row. I don't want you to have to look at every row. I only want you to find the rows that don't have it. That act of looking for equality, or in this case, inequality, because they're not in there, it forces SQL Server to process every single row. When really there are only less than 1,200 rows that are missing an email address. So that's all we want to do. We just want to look at the 1,200. We don't want to look at the other 18,000 or whatever it is. So a better way to do this is using the not exists keywords. We can say where this not exists from, and we're doing the join in the where clause in this not exists note. One other funny thing, some people try to be cute. You see how I put select one. You could put anything in there because the select clause in that subquery for the not exist, and that joined query, I should say, it's ignored entirely. I see people just, to be cute, they'll put select 1 over 0, which of course would result in a null value and an error if you just said select 1 divided by 0. But if you put it here, it's completely ignored. So kind of a side note, why it says select 1. You could put select star in there. Please don't. It won't do anything, but it's bad to see that. Anyhow, the reason we call it avoiding the semi, because we want this right anti-semi join. Anti meaning we're looking for the absence of data. If we were looking for where exists, we'd have a right semi-join. But the key thing here, we're not evaluating and looking for equality or inequality of almost 20,000 rows. We're going straight to just evaluating the nearly 1,200 rows that we need. We can look at the actual CPU time. Here's another way to measure the metrics of these two queries. That right outer join, you can see takes 0.013 seconds. This right anti-semi join takes about 50% less, 0.008 milliseconds. All right, so that's the last of the join. The join anti-patterns. Any questions?
Floor is open. Just to let you know, Jeff, I so appreciate your slides.
I'm glad. So I'm always worried there's going to be somebody who hates dogs or was bit by a dog and is just going to be really offended by this. But anyhow, try to keep it visually interesting, right, as we go along here. All right. Yeah. If there's no questions, or is there a question?
John, did you have a question? Nope. Oh, Andre? All right. All right. Back on.
Moving on. Let's move to the last section here, predicate anti-patterns, where we'll see the anti-patterns in the where clause that, again, these are going to be some of the more complicated ones you'll see. They have a little more complicated solutions, but I'm sure you've seen these as well in code that you're supporting. All right, request number 6. Hey, I was born in 2012. It is my favorite year. Let's find out how many orders we had that year because it is my favorite year. So we have to go, Junior has to go find all the orders for 2012. So Junior declares a variable and then runs a select count from that year using the year function against order date, which is the anti-pattern. I saw actually a client with this today, and send them an email like, hey, you're doing something here that probably could be improved. I'm going to call this fallacious arguments, because you'll see in a minute we're talking about arguments, right? Now, one of the things here, let me back it up. If you do this, you would think if we have a non-clustered index on order date, that we should be able to go and just go straight to the 2012s, like, okay, these should be in order. But unfortunately, we're not going to get that. We're not going to get an index seek. That's what we're looking for here, where we go straight to the data we need and then just continue reading from there, whether that's one record or 100 records. Instead, we have to do an index scan. Now, what that means is then the SQL Server has to evaluate all the rows in this non-clustered index that we have on order date. And why does it have to do that? Because, well, this query is what's referred to as not sargable. If you've seen this word, like antipattern, this is another word that people use that sounds kind of jargony, but it comes from two really important words. Sargable means it's not able, that your query is not able to efficiently use an index for a search argument. And the search argument that we have set up of using the function of looking for the year on the data to match a variable isn't sargable because it's clearly not efficient. It's causing a scan instead of a seek. So let's take a moment to talk about what else is not sargable, because Junior is asking there, right? So most functions really that we're performing on our data values on the columns are not sargable. Anytime, like even date add, you see something like this is not sargable. This is going to result in a scan and not a seek. Conversions of any kind, cast or convert. Anytime we're converting the data, that's not sargable because SQL Server has to go change all the data to figure out, well, then what would it look like after I change it? Operators, any kind of mathematical operations that we're going to be using, any calculations. SQL Server may know what the total do is, but it doesn't know what total do is minus 1,000 would be. Concatenating columns. If you put two columns together, well, it doesn't know what that is. Even if they're in the same index, it's the way the B tree is structured. These values are stored separately, so it can't just instantly seek to a first plus last name. Anytime we use like with a leading wildcard, all bets are off. It doesn't know. Now, if you have a trailing wildcard on an index column, then that should actually result in a seek. But the leading wildcard, no go. You're going to get a scan. And case statements, of course, because SQL has to evaluate all these things individually. So how do we solve this anti-pattern? Well, when I started the very first SQL Saturday that I went to, gosh, I don't know how many years ago, this gentleman, his name's Vern Robbie, is from Oregon. I don't think he's presenting anymore, but he used a phrase that resonated with me, and I hope it resonates with you when you start seeing these sorts of things in your query. Embrace verbosity. And what I mean by that is use more words, write more T-SQL to tell the SQL Server query optimizer exactly what you want so you can get it quicker. Write more T-SQL to get faster results, to take less time. So one better way to write that whole query is, well, it's a little bit more difficult, right? So we're going to create two variables, and I'll say start date is this and end date is that. The beginning, January 1st of 2012, and the end date is December 31st of 2012. And we're going to select a count where the order is between these two variables. And because of that, we're not performing any operations at all on the where order date part is. We're just looking for things between a particular date range, which is exactly what we wanted, right? When we said, I want year equal to be 2012. Sure, slapping the year on order function on order date is really easy, but it's making SQL Server do all the hard work. Doing it this way, a better way, we're going to get an index seek. Now, you're a lively audience, so I know you folks are paying attention. You probably noticed, I know some of you, if not all of you, have noticed that there is a flaw in here with what I just wrote, which is, what about 12:31 after midnight? Because if I do 12:31, well, it's only 12:31 at 0 hours, right? Any orders placed after midnight wouldn't have been included, and you're right. So, that's kind of a problem. That only goes up to the the very start of the last day of the year. Fortunately for me, though, there are no times in the stored in the date time values in AdventureWorks. So we'd actually get all the orders, but that's not helpful for your code. So let's show a better way to do this. This is a common way that I use, which actually only uses one variable. And you'll see here what we've done. We're still using a function. We're using a data add function, but we're not using it on the data column. We're using the function on the variable. So I only have to transfer one thing. I only have to I only have to calculate the date add for one value, and that's the variable, rather than everything in the order header table for order date.
Oh yeah.
This is also going to get us an index seek. The way I'm doing it here is I start with January 1st, 0 hour. You take anything greater than or equal to that, and then add a year, let anything less than that. So 0 hour of January 1st of 2013. This is a good way to do that anytime you have to calculate kind of annual things within a. There are other ways to do it too. I just want to emphasize to make sure that you're not slapping those functions right on the order date or any other corresponding column. So why is this faster, right? We're doing a lot less logical reads. We don't have to scan the entire index. Now, this is a tiny index. It's only got 73 pages, but instead of reading all of them, we can just go read the 12 pages that have the data for 2012 that we need. Any questions about that?
Anyone? John? Tammy?
I got one. Is this searchable? Something seems like I've heard that it improved over the different versions of SQL. It does a better job of it. Is that a true statement, or am I thinking about something else?
You might be thinking about something else. Now, there are some date functions that are startable, but there's not really been a march to improve that. Really, the improvement is going to be made from you within your queries to make sure that you're meeting all of those requirements, or you're not doing any of those things that I showed, where you're performing any kind of conversions or functions or calculations on columns in tables. That if you're matching, if at all possible, you can perform those things on a variable instead, if you have to join to a variable for a predicate. Now, sometimes you may have to perform those kinds of functions to match disparate data, and unfortunately, that's just, that's going to have to result in a scan. There's no way around that if the data doesn't match. Like, let's say I have to match, I have a name field here that's a full name, and I have to match it to the first name or whatever of another column. And so I have to just take the first part and perform that function. So again, SQL Server doesn't know what that is. It's going to have to go calculate that for every value before it can join those values.
Thank you.
Thanks.
All right, I'll move on to the next one. We're getting close to the end here. Boss request number 7. Hey, I need a report to find any orders shipped on a given day or any unshipped orders. Also, I'm tired and wish to take a nap. I know the feeling. It's been a long day. So what we're looking for here, Junior's going to write some code. Junior's going to write a store procedure in this time. And Junior's going to have to account for, sometimes I'm going to pass a particular ship date, or any other user will pass a particular ship date to get some values, or sometimes the ship date will not be passed, and if it's null, we need to account for that and then just give the null values. That gets a little tricky, right? Because sometimes we have to have values and sometimes we have to have nulls. So what happens here, Junior writes a query that looks something like this. I'm going to do an is null on the ship date and an is null on the ship date variable parameter that's being used. So now, savvy viewers will note that we just talked about performing functions on columns, so we know already that that is an anti-pattern. But this is something in particular because we're talking about nulls. I'm going to call this anti-pattern a lot of nothing, because I've seen this as a common way to handle nulls. And what this does is, we get the deja vu of not being sargable. It's an index scan. Now, a better way to look for nulls would be to instead create the store procedure or something like this logic, where the ship date matches it, or we're looking at specific values of null and is null, rather than using the is null function. That's going to allow us to get the index seek that we want, which in this case, oh, look, we got 0 rows, so none of them are null. Awesome, at least not at the moment. An even better way, though, than doing that, and I'll show you again here. I mean, these are in the slides you can get in the repository, but an even better way is to use the intersect command. If you're not familiar with this is a great command supported in most versions, most SQL databases. And this will give you the same sort of result. We're going to get an index seek, but intersect allows you to make a comparison between two things, two sets of data, two variables, or two values in this case. And then we can see where those exist. And intersect supports nulls. So we don't have to put anything in there to say specifically look for nulls. Now, a little bit more about intersect, just at a really high level. Whereas interjoin matches data, intersect just is finding distinct common values. There's a slight difference there, right? Matching data with an interjoin means I won't match on nulls, but nulls will be matched when we're looking for distinct common values using intersect. Using a Venn diagram here, you can see we're looking for the commonalities between two sets of data. Now, there are two rules if you are going to use intersect. The first is that your column names and your order of those columns when you're doing an intersect must match. If they're out of order, you're not going to match, you're not going to get anything in your result set. Another important thing that you can't do, your column data types must match as well. So you can't do a convert or whatever if they don't match. Intersect has very strict rules, but again, it can give you a big performance improvement by giving you less logical reads. If we compare these two, one was doing a scan, one's doing a seek. This is only doing 2 logical page reads because we didn't really have any nulls, and it was just reading the allocation pages or whatever. So, any questions about intersect?
Laura? None? John? Tammy? Abdul? Andre? Eric?
No.
All right.
All right.
I'll move on to the last one here. Last final request from the boss. Hey, we got a chargeback, and we might have more chargebacks. We need to find the sales ID for an approval code. I will slack you the code and take another nap. If you ever wanted to work for a dog, maybe it's not the best boss, but I don't know. Work from home has advantages, I guess. So Junior writes this query. Get the shipped orders with an approval code, and then says, all right, go find me these with the approval code. Now, with the naked eye, there's nothing wrong with this at all. There's no anti-pattern here that's visible. But if we take a closer look at that sales order header table, we will see that the data type of n variable character doesn't match variable character for the credit card approval code. Now, a lot of times we see people writing, I've seen, not saying it's you, but I've seen people write code and they think, well, I'm going to create some sort of, when I create my parameters in my stored procedure, I'm going to use data types that are the most inclusive if possible. But that can backfire, as you'll soon see. You definitely want to make sure you always match those. If not, you're going to get what I'll call involuntary conversion. And you'll see there's something different here with the execution plan we're looking at. There's this nice yellow triangle with an exclamation point, or as they like to say in the UK, a bang right there on it. And if you look at that bang, it's giving you an index scan, right? Let's highlight over that select and see what it says. There's a warning. Never a good sign when you see that if you look at your execution plan. And there's a lot of wording in there about type conversion in this expression, convert implicit. Convert implicit means there had to be a conversion and you didn't ask for it. So we had to convert the data, and it may affect the seek plan and query plan choice. That's always awesome, right? Especially when you have a much larger query plan, and who knows what's going wrong here. SQL's doing a lot of extra work. Now, when we say implicit conversion, one of the things we need to talk about really when we see what gets converted and what doesn't is precedence. Not precedence. Precedence. Precedence relates to an organization, a prioritization, excuse me, of different data types. So let me show you an example here of these are some of the data types that we have. Here's the fine print. There's over 30 different data types. This is just some of the more commonly used ones. When we talk about precedence to determine what gets converted and what doesn't, data of lower precedence, in other words, the stuff toward the bottom of this particular chart, has to be implicitly converted to data of higher precedence. If you have different data types and you're trying to match them, either through a join or by creating a variable that doesn't match, you're going to have this implicit conversion. In our case, the credit card approval code parameter that we've created is Unicode and variable character, which is a higher precedence than variable character. So that means SQL Server said, okay, what's the lower precedence? It's the values in the table. I've got to upconvert all those values in the table up to n variable character. I got to create all of them and then see which ones match.
Mhm.
Better way is pretty straightforward. Make sure your data types match, right? Then you get an index seek. You don't get that other kind of goofy stuff. Now, I will leave you with one really neat thing. You can Google SQL Authority, find implicit conversion, and go look and see this this query right here from Pino Dave, who you know as SQL Authority, presumably. Here's the link for this. This is a very old query, still a very helpful query. What this query does, you can take this query, you can go look at the query plans that are right now in the DMVs for the query stats for your queries on your servers right now. And you can look for this and you'll see it says like convert implicit, and it will find plans, in this case, the top 50 plans by estimated time, by total worker time, excuse me, that have implicit conversions. You can find those queries and go, hey, are these in the stored procedure? Is this something I can go quickly fix and reduce the amount of extra workload in your queries? So you just create a baseline, show your improvement, go get a raise, right? All right, let's wrap this up here. Boss has a final ask. Hey, I just woke up from a nap and I wanted to reach out to briefly touch base with a final ask to see if we can circle back for a helicopter view, because this is the way managers talk, right? So Junior, it's been a lot thrown at poor Junior here, right? And so all they remember is something about index seeks, confusing execution plans, and a bunch of dog pictures. Hopefully you have got more from this session. If not, here's a quick summary of what we talked about. First, we talked about unnatural selection and using select star. Solution is to limit your column selection. We talked about using select distinct. It's the same as group by. Try where in instead, or rearranging the columns, or excuse me, using additional columns in your joins to make sure you don't need to have distinct to remove duplicate rows. We talked about the dysfunction of user-defined functions. Maybe you could use newer versions that might help with that. Otherwise, you might want to consider not using functions if you don't have to improve query performance and reduce the anti-patterns. Talked about joinzillas and how you can tell if you have too many tables in your query by the that really long phrase that I can never remember the end of, and I told you I wasn't going to say it again. But when it says timeout instead of good enough plan found, the solution, of course, break it up using temp tables or whatever you think. Table variables can work if you have small data sets, small enough data sets, like a few hundred rows or less. But generally speaking, temp tables, if you're materializing that data, can be more helpful. Avoiding the semi where we have left joins with where null. Hopefully you can use where not exists now, replace those left joins where null to get better performance. Use less resources. We talked about sargable queries and embracing verbosity to get tell SQL Server more words and get the results back in less time. We talked about how to handle nulls using exists and intersect. And lastly, we talked about implicit conversions and wanting to make sure you matched all your data types. That is the end of the session. So I want to thank Seven and Daphne for their contributions to this. Again, you can see all of my slides. You can go to desertdba.com if that's all you remember. And there's a presentations page there that will take you to my GitHub repository. You can go straight to the GitHub repository you want, and if you want, and download all these slides. Try these scripts out yourself and see what's going on. And if you have any questions, if you think of anything after I unplug here in just a few minutes, feel free to email me, jeff@desertdba.com.
Perfect. Jeff, are these your dogs, Daphne and Seven?
Yes.
Oh, nice. All right, the floor is open. John, Tammy, Abdul, Andre, Mike, Eric, any questions?
Just want to say thank you. It was a
Yeah,
great
let's thank you,
presentation.
man.
Appreciate it.
Really
Yeah,
excited.
really good info.
Well, thank
Great
you.
slides, love them. Very interactive, Jeff. Thank you.
I do have one for you though. This
Sure.
one's a little challenging. Are you
Okay.
familiar with the parameter sniffing in 2022? They did an improvement on that.
Yes.
And how
Oh.
is that different than the variables in the queries you were looking at?
Well, the parameter sniffing changes that have been made in 2022, those that I don't know that that's going to relate to using variables or table variables or temp tables so much. There's still some issues with table variables. So, you know, again, it's a variable, but it's a table, so it's kind of a not really the same as all your other variables. So most of the parameter sniffing improvements will apply to those other variables where you have like a single value of an integer or a character string or whatever that's passed, and SQL Server will store in the query store different execution plans for different ones. And so it kind of has them as like, oh, I know you need this plan instead because you only have 1 or 2 rows that match this, or it'll say, oh, you've got a whole lot of data with that particular parameter. I'm going to run this different execution plan instead. I don't know how that's going to work really with table variables, but that's a great point to mention.
Thank you.
Anybody else have any other questions? John, it looks like you got one coming aboard here.
Well, yeah, I was thinking of one. It had to do with the intersect using the lot of nothing. And I wondered if you had an example where you could use a union instead of an intersect to also see performance improvement.
Yeah, that might work as well, depending on how you had to have that. You could break that into 2 separate queries because in the first solution before the intersect, I did an or statement, and your union would effectively do the same sort of thing. So now it would create 2 passes of the data, but I guess if you needed to find both of them, that would work. If it was an and statement, like I need the nulls and this other value, then the union would work. But if you needed to find one or the other, then the union would be additional work.
I see.
Great question.
Okay.
Great question. Tammy, do you have any questions? No?
No more questions,
Right.
I think.
Floor's open. Andre, Mike, Jack? Any last minute questions? Well, Jeff, we thank you once again for being our sponsor this evening. Definitely great information, definitely great slides. Probably one of the best I've seen so far in a long time.
Thank you.
Great.
All of you stay safe, stay healthy, and have a great night. Once again, Jeff, thank you very much.
All right, thank you for having me. It was my pleasure.
All right, take care.
Bye.
Take care. Good night.
Yep, thanks.